Okay, welcome back. Applications, system of equations. This was a little tougher. All right, Andrew was a superstar high school basketball player. I forgot to put in high school, but he was a superstar in high school. This person. He once scored 52 points in one game. Wow, that's a lot for a high school game. It's really a lot. The number of 2-point baskets he made was 2 more than his free throws. The number of 3-point baskets that he made was 4 less than his 2-point baskets. How many of each basket did he have? So I've told you guys in the past that our question will usually tell us what we're going to use for the variable. So when it says how many of each basket did he have, look, I assign the variables to each type of basket. So X would be the number of free throws. Y would be the number of 2-point baskets. Z would be the number of 3-point baskets. So we need to make 3 equations for each of the 3 variables that we have. One of the equations is going to come from this. It says he once scored 52 points in one game. I still can't get over how many points that is for one game. That's a lot. So let's make an equation for that. It would be X, number of free throws. They're worth 1. A free throw's worth 1. So 1 times X, or just X, plus 2-point basket, 2 times Y, plus 3-point basket, 3 times Z equals 52. Okay, good. Now the other equations I think are a little harder to set up. It says the number of 2-point baskets he made was 2 more than his free throws. So I'm going to start by saying X equals Y, which is not true. The statement that I just said is that the free throws was the same as the 2-point baskets. But that's not true, because it says here that it was 2 more 2-point baskets than his free throws. So one of these numbers is too small. Which one of these is too small? What's smaller, free throws or 2-point baskets? Free throws is smaller, and I need these equations to be equal. So I'm going to add 2, because that's what 2 more than means, is to add 2. But where do I add 2 to? Do I add it to the X or to the Y? Well, I need to make them equal. Right now they're not, so I need to add it to the side that's smaller, so I'm going to add it here. That takes practice, but once you get it, you get it. And you can really understand it if you really think critically about it, okay? We have another one of those same types to set up right here. It says the number of 3-point baskets, which is Z, was 4 less than his 2-point baskets, which again, the 2-point is Y. So I'm going to start by saying Y equals Z. Y equals Z, which isn't true. Z is smaller. He made less 3s, more 2s. Y is bigger. Y is too big. We need to make Y smaller by subtracting 4 from Y. So this is going to be Y minus 4. I want somebody to tell me that they don't get it, because I want a chance to explain. And I really want you to understand this. So somebody tell me you don't get it, okay? Once you get this, these type of problems aren't going to be that bad. Now I've got a system of equations with 3 variables and 3 equations. I have enough information to solve. And if you remember, the best way to solve a 3x3 system, I think the most efficient way, is to make a matrix. I think making a matrix or building a matrix is so much more efficient. So I'm going to erase all this work. You can always rewind it if you need to revisit the information. But before we make a matrix, we got a little bit of an issue here. When you have a matrix, you need all the variables in order on the left side and what they're equal to on the right side, okay? Otherwise your matrix will not work. So this Y is out of place, kind of like standard form, remember that? And this 2 needs to go over. Okay, hold on one second. So the first equation is fine. I'm going to rewrite that system of equations in an order that we like better. So I'll call it X plus 2Y plus 3Z equals 52. And if I move the Y to the left by subtracting it, and I move the 2 to the right by subtracting it, I will have x minus y, and this first one does not have a z term, but that's okay, equals negative 2. And in the last equation, it doesn't have an x term, but that's okay. We'll write that as y, or this y, and if I subtract z from both sides, minus z, and if I add 4 to both sides, equals 4. And now, we're ready to set up our matrix. What do you think is gonna go where the z term is missing and where the x term is missing? 0. So here I have 1, 2, 3, and 52. And here I have 1, negative 1, 0, negative 2. And here I have 0, 1, negative 1, and 4. All right? Any questions? So now let's plug that into our matrix. One, 2, 3, 52 on the first row. 1, negative 1, 0, negative 2 on the second row. And 1, negative 1, and 4 on the third row. Oh, I'm sorry, 0, 1, negative 1, and 4. And then we'll go, all right, and you get this matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1, 9, 11, and 7. So that means my x equals 9, read those. And my y equals 11, 2 pointers. Is that okay? 2 pointers. And then my z equals 7 3-pointers or baskets, whatever you want to call it. All right. What do you think? I hope you liked it. All right. Let's give some of these a shot. That was the last lesson before the test. We'll have a review. I'll put some videos up for the review. Next time we meet, you'll have them ready. Good luck on it. Have a wonderful day.